Okay, and welcome to Flat Earth Civil Discourse, episode 14 with Ebon Kim. Thank you so much for joining us here.
Thank you for inviting me.
Hold on a second. I need to forgot to hit the mute button. Ebon, I just now, within the last couple of days, just got to hear of you from Slick James Johnson, who's been a civil discourse participant here. So just tell me a little bit about yourself, because we really don't have any kind of relationship other than, hey, you want to do a hangout together? So
Yep, that's the way it seems to go. But yeah, okay. So I've been just having this waking up process back in 2016. It started politically with Bernie Sanders. He seemed to resonate, and but then things changed, and um, you know what ended up happening is I started to do my own videos on YouTube and got with other people who were just kind of, what he was saying resonated with a lot of people. He seemed to be, just speaking from himself and not from like someone who wrote a script for him to say what he's supposed to be saying.
You mean Bernie, right?
Bernie Sanders,
yes,
yeah.
Yes.
And today's Bernie Sanders is different than when he was running in 2016. So I'm not the same way. I don't follow him like I did back then, and I'm pretty sure some people are the same way. But then things like so that kind of died down, and I kind of went away from politics. Then I started diving into rabbit holes and a whole bunch of other things, and then of course all the other rabbit holes and conspiracy theories kind of went down to flat earth. And I was like, okay, it's time to look into flat earth for a little bit, because there's plenty of times where I've researched more into NASA and the moon landings, and the more I looked into it, I was going, okay, most likely we didn't go. Okay. And anytime I even mention that, and just some of the things I found out on my own, of course, there's all these YouTube channels, and there's certain things that someone says, this is why it's debunked that we did go to the moon. And here's other ones of, this is why we didn't go to the moon landings. But it's basically up to me to find out, hey, with all the information that's provided and looking at all the details myself, I don't think we went. But then anytime I mention that, the people who are just die hard, we went to the moon, people just shut the dialogue down. It's like, you're crazy. I'm done with you. I'm like, really? You're going to just throw away, months or years worth of just talking? Now you just don't even want to talk to me because I even questioned that the moon landings probably didn't happen. And I always throw that in there. It's not even a definite yes or no that I know positively. I just say, probably didn't go. And then flat earth, I was looking through, I actually went through all of Mark Sargent's flat earth clues, and I still wasn't convinced. I still didn't have that doubt for sure that the earth might not be round or a globe. And it took me watching a PBS show, and I think it was on Discovery Channel as well. It was Stephen
Hawking's,
yeah,
and Genius, I think it was called.
Yeah, Genius. And it was the last episode of the first season. I think they only had one season. And they went through the whole dynamic of, okay, we've got a helicopter flying over the horizon, over a body of water, and we've got a telescope. So the helicopter lands, and we see it go beyond the water. So it's like, okay, Earth looks pretty round to me. I mean, that's one observation that could be made. And then it goes up, but they reuse the same footage, and the reason I know this, other people,
the bird flying by, and
the three birds. Yep.
Oops,
and I watched the other YouTube channels that say, hey, look at these three birds, and instead of looking at their video, I just made my own video. I just screenshot it, because I could record wherever I want, anything that played it back in my video editor, just frame by frame, just made everything the same, and they're just slightly off as far as the timing. But if you just do, the snapshot by snapshot, exactly the same, except for that center reticule, you'll see the helicopter going up instead of down. So
Yeah,
it took Stephen Hawking
they definitely faked that footage.
Yes.
So, yeah, so it's an interesting journey, and I don't know. Are you familiar with the Netflix documentary? Is it Beyond the Curve? The
Beyond, yeah. I heard about it. I still didn't watch it because
Okay.
I just know where it's going, and
I'd recommend that you watch it.
Yeah.
Because it really is a thoughtful presentation of here's what the globe Earth people believe, here's what the flat Earth people believe. Obviously the documentary filmmakers are on the side of the globe, but and obviously I'm on the side of the globe, but it seemed that the documentary, like it wasn't just like, oh, here are these ridiculous, wacko. It was a sensitive treatment. They went to their homes and they had long form interviews, and it was, I thought it was very well done. But
Okay.
the reason why I bring that up is at the very end of the movie, there's some kind of a meetup of like astrophysicists or something. It's like, flat earthers have meetups. Well, apparently astrophysicists have meetups as well. So it was at some bar and there was a whole bunch of people there, and they had actually a whole bunch of people get up and, get on the mic talking about science and rocketry and all this kind of stuff. But this one guy gets up and he says, if you encounter people who don't believe the same as you, you really need to take a serious look at their argument and why they think the way they do, because and you've experienced this, in the flat Earth debate, that there is a lot of vitriol. So, somebody says, I believe the Earth is flat, and then a glober is like, hellfire and, just rounds on target, just try to destroy the person, and it's like, well, do you think you're going to change any minds if you're just firing howitzers, So this astrophysicist, he was really good. He was like, it takes seriously, if like, let's say you're working on planetary research and there's somebody who doesn't believe that planets are real, like, listen to them, listen to their arguments and ask them, how they came to those conclusions. And, what he was advocating was really building bridges and going for understanding. And that's kind of what I try to do with these conversations is, like, obviously you and I disagree about the shape of the Earth. We disagree about the moon landings, but we can talk and have a civil conversation without, without trying to destroy each other,
Yeah. And that's all that really matters.
So,
at least to me, and really all of us, we're all in this together.
yeah.
I mean, look at all of the things that are happening around the world, and that if we can't even agree what the shape of the Earth is, how are we going to do anything about all the other problems?
Yeah. It's kind of a fundamental, fact that, like, the Earth is the shape it is. Like, the Earth, the shape of the Earth does not care about mankind. It does not care about opinions, of people. It is, and I've been talking with not talking, but in the comments with Slick Willie, or Slick, what do I call him? Slick James Johnson. Oh my goodness. And I've been talking about objective reality, or, like, he's been talking about reality, and he's like, well, who says what objective reality is? And my point is that objective reality, it is what it is. It's like, God's eye view of things, an omniscient third party who knows all, sees all. Okay, that's objective reality. And then you've got your subjective realities from all the participants. And the thing is, objective reality, it is what it is. Now, whether it's knowable or not, is another debate. Like I always argue that, that the Earth is a globe, but it can't be proven because we could be in a simulation. We could be, I guess the phrase they use is brains in a jar. And so if you think about the Matrix, there's these guys are living their lives, but they're actually in a simulation. And occasionally there's a glitch in the Matrix, like that cat, walks by twice, So my, my personal belief is that either we are living in a simulation in which case the simulation that's been presented to our eyes is a heliocentric one, or we're living in the real world, in which case we live in a heliocentric reality, but we can't prove it either way. What I do say is that it can't, the evidence presented shows that it's not flat. Is there anything that kind of swayed you to the flat side? I mean, I know you were kind of not really a big fan of NASA with, not believing the moon landings, but what are your thoughts on like what puts you over onto the flat side?
Just the establishment, really. The power players, the ones who are the ones that tell everybody this is what it is. And I think that's where Slick James has a good point of what objective reality is. Is it just the majority stating one thing, or one person stating one thing, and that person is a person of authority, and then that person of authority, everyone either looks up to or are forced to abide by it, or if you're going to disagree, you're just going to be silenced one way or another, or something like that. So I'm more for the underdog, and if it is exactly as what everyone says it is, it should be pretty easy to point out. We all have these little things like, hey, if it really is, couldn't you guys just do this thing? I mean, it's really simple. And then they either ignore it, or they go, no, it's really hard. I mean, having a GoPro not in the super wide angle lens mode, I mean, it'll cost us like $200 million. So no, we can't do that. Those types of things just kind of, all right. I don't care anymore. I have my own opinions on it. And if you're just going to sidestep me each time, you don't need to prove anything to me. If I talk with someone, you're either going to provide some wisdom, which I can grab onto, and I'll use that, because I'll listen to what you say, look at some of the things that you've looked at, and make my own decision on it. But if it's just a bunch of rhetoric where you've got an audience and you're just trying to persuade the audience to look at a perspective a certain way, which is pretty much your way, then I'm not going to learn anything from it. I'm not going to gain anything from it. I'm just going to go about my usual way,
Yeah, that's a very good point. There's a lot of globe earthers who do try to use rhetoric to, like, they want to logically build the argument. I mean, there's nothing wrong with rhetoric, but I get what you're saying about, the person's trying to have their argument be logically superior to their opponent's argument, and it's like, well, that's nice for like debate team, but if we're really trying to change minds, somebody who's the victim of superior rhetoric isn't going to necessarily say, well, I guess you're right, because your argument was better than my argument,
Yeah.
It's not going to change anybody's, opinion. So I do see what you're saying there, but I just watched a little teeny clip that you had made where you're talking about, I think you were over at the Non Sequitur show a couple weeks ago, and there was Red's rhetoric, and I guess it was not Steve, it was the other guy.
The godless.
Oh, godless engineer, but no, it's
Yep.
the guy who took over the show. So Steve McRae's out, but it's the other guy. Well, anyway, so they were in, and you were talking with them, and you kind of made a little video, sort of, analyzing it. And you were saying that Red's rhetoric was, simply using rhetoric, and I think you missed something that he said, which was, you can do this stuff yourself. I mean, he made a couple flippant remarks like, oh, I don't care about history, and reality is, because it's so obvious, or something like that. I mean, he can have a little flippant style. But the key message that he was saying, at least to me, was that you can go out and you can do this stuff yourself, whether it's filming the ISS, transiting the moon or transiting the sun, or and he had a partner, Astronomy Live, and they actually triangulated the distance to the ISS. Are you familiar with that? With that exploration they did about a year ago?
Not really.
Yeah. Okay. Yeah. So normally you can't triangulate something unless you've got a baseline. So he paired up with Astronomy Live, and they both watched the ISS transit the moon, and then did the math, and they were able to figure out the distance, and they got to be within like 1% of the of the NASA figure. And so like that was one of his points, was like, you could do this stuff yourself. Like you don't have to believe his rhetoric. So.
Sure. But when we look at something up in the sky, do we necessarily know what the shape of what we're looking at from is?
Yeah, that's a very, very good point. So and at some point I'm going to make a video on this, because that's one of the biggest arguments about in the flat earth debate, when someone suggests, like me, because like my wheelhouse is the sun, moon, and stars. So I suggest that people look up, and they're like, oh, well, looking at the sky is a fallacy because the shape of the ceiling doesn't tell you the shape of the floor, and that sounds compelling. And because it is kind of true. I mean, you go to a, like most rooms have a flat ceiling and a flat floor, but there are exceptions. You go to a planetarium, it has a dome ceiling and a flat floor, or you go to a stadium seating movie theater, which usually the ceilings and those things are kind of boxy and rectangular because the building's rectangular. So the ceiling will be flat, but then the floor is sloping, So it's like, that's a good argument. The shape of the ceiling doesn't tell you the shape of the floor. Okay, I get that. But what that argument doesn't it doesn't acknowledge is that I'm not talking about the shape of the ceiling, and that's the key. When I tell people, and I don't know if you've looked at any of the stuff on my channel, like any of the explorations.
Some of it.
Okay.
Yeah.
So I don't talk about what the shape of the ceiling is. I talk about analyzing the paths of things, in the sky. Because the ceiling, and, if you think about this, if you just sort of, imagine there's nobody on Earth, just you, and like the Earth is either flat or it's a really huge sphere. But like if you zoom down to your level, okay, it's locally flat, so you can put a little dot and a horizontal line. Horizontal line represents the Earth. Okay. And it works in both the globe Earth or the flat Earth model, because to the scale of your little person on your little drawing, the Earth does appear to be flat. Right. But what's the shape of the sky? The shape of the sky is a hemisphere. It is, and it's always a hemisphere. I mean, unless you're, under a bridge or something. Because like you could see north, south, east, west. So that's 360 degrees around you, and you can see 180 degrees overhead. So no matter where you are, if you have clear skies, and if you're not in the bottom of a canyon, if you've got clear horizons and clear skies, the shape of the sky is a hemisphere, and that works for both flat Earth and globe Earth. So that's not my argument,
Mm-hmm.
Anyway, I don't want to.
Well, my argument is the current establishment that pushes globe Earth, and to even think about that the Earth is flat is just wrong. They tell us that the Earth was proven to be a globe 2,000 plus years ago. And so when we look at history, and this is the great thing about flat Earth, even if you don't think the Earth is flat, the flat Earth model, it makes you look at things from the perspective of, if the Earth is flat, then let's look back at history. What happened? And with the globe Earth, the history doesn't really matter. With globe Earth, it's science fiction. It's about space travel. It's about inhabiting other worlds. The past really doesn't matter if you are in the globe Earth model. It's just about moving forward. Now, with the flat Earth model, you're going to be looking back, and you're going to be looking at all the reasons that they're stating that the Earth was proven to be a globe over 2,000 years ago. Now, over 2,000 years ago, we didn't have telescopes. Telescopes weren't around until about the 1700s. And also the North Pole. Now, I'm not sure if you know about this with the history. The North Pole wasn't explored until maybe around 1908, 1909. And it's attributed to two different people who went there. One saying they went, not this other person first. But the thing is, the meter was established as a certain distance from the North Pole to the equator, going through a meridian in Paris. This is the French where they came up with the meter, and it was one something whatever, and
some fraction of the circumference, right?
Yep. And that's how they established the meter. Except this was back in around 1718 or something like that. And it's like, okay, so how did they know where the North Pole was if no one ever discovered it until they said it was like around 1909? These things don't make sense. What's wrong with this history? And so And you keep going further back, and again with the binoculars. So can we prove that the Earth is a globe without using instrumentations like telescopes and just the things that they had back from maybe probably around 500 BC is when they first attributed, okay, the Earth is probably a globe, and then it went down to around 200 BC where they're saying, okay, yeah, this is the current model from the Greeks that, yeah, the Earth is a globe after Plato, Socrates and Plato. So once it hit Aristotle's saying everything's subjective, it's not really objective. And, instead of this model of a dome, the Earth and the stars, it's different than what
Yeah.
Plato has. So things started changing from there, and then goes down to Eratosthenes. So it's great because not only do you start to look into the science and technology a lot more. I mean, I started with science and technology anyways, but you also go and dive into the history that's been presented in the established model back in, whether it's in public schools, whether it's in colleges, whether it's on just nasa.gov or the Smithsonian, whatever big establishment history that tells the history of mankind, I guess. And you're going to hear the same thing. You're going to listen to the same thing, and it's great. You get to just see where everything kind of stemmed from, and you go into other places. Like, I don't even really care about the shape of the Earth too much, really. I know it'll piss people off, but it's just the frame of mind, the frame of thinking that thinking that the Earth is flat and the current globe Earth model has been either a big lie or whatever it is. But you start thinking a different way, and you look at things a certain way, and it's beautiful. Whether it's flat or globe, it's beautiful.
Well, one of the things that I do agree with you there, that we do live on a wondrous world. And one of the things that really appeals to me about the flat Earth debate is that I am driven to learn so much science and history. Although I haven't focused on the history lately. I mean, I guess I'm guilty of what you were saying, where it's like you're looking forward to the future. But I've learned more science. Like, I started participating in the flat Earth debate about 11 years ago. It was March 2008. Yeah. So it's been over 11 years. And I didn't start on YouTube until like 2 years ago. But so I was pretty active participant, creating graphics and debating these guys. And the debate was really very, very different 10 years ago. But the point that I'm trying to make is that I've learned more science in the last 10 years. Actually, I've learned more science in the last 2 years now that I've joined YouTube, that I've learned in the previous 20. And so that's really appealing to me, is because I do love learning. But especially if it's guided, if it's guided towards something. But I want to touch on a little bit what you said about, see, you say that globe earthers don't, at least they don't focus on the history. And I think, and then what's his name? Slick James is talking about this. He's like, what did the ancients know? What did they know 5,000 years ago? And so it's good to sort of do a tabula rasa, like let's wipe the slate clean and let's pretend, we don't have any technology. We're just looking at the sky, or we're just looking at the sea and the land, and what can we figure out? And I think there is a compelling, there's compelling evidence that even if you had no telescope, if all you could do is you could just see the sky and you could see the ocean, that you could figure out that the Earth is a globe, and you can actually measure it. Of course, the measuring part, you'd need something like a theodolite. But it's good to be skeptical. And I think that's one of the things that you really strike me as you're a skeptic. And I think skepticism is a really, really good trait to have. As long as it's like, skepticism followed by, a fair investigation, like, hey, let's take a look at both sides, and let's, see their arguments, and let's see their evidence, and, kind of hash things out. But I mean, I agree with you in that, it's good to not just absorb what we're being told, So I don't know. That makes sense.
Yeah, I mean, my initial major was a double major at University of Washington, and it was for psychology and zoology. And so I worked with the China Infant Lab at the University of Washington, and totally different story there. But it's imagine you've got an experiment that someone did, and they go, hey, here, try it. And you try it, and you look at it and you go, I think there's something wrong here. I mean, if I run it your way, yeah, I could run it 100%, but I think there's just something wrong with the way that you're running the experiment. And you tell them, and they go, no, my experiment's fine. And then I go out to other people, and they go, yeah, I think you're right. I think it should be run this way, and see what happens. And of course, it doesn't run 100%. There's some oddities there, anomalies you would call it, and you're just supposed to ignore the anomalies. And we go, no. We should focus on the anomalies so we can figure out what it is, and because it's a mystery. And then you've got other people who are saying, no, the science is right. Look at his accreditations and look at your accreditations, and it's based on accreditations. And then
Right.
Okay, so then I'll go out there and it's like, okay, now I just need to find someone who's more accredited and see what that person thinks, and that person would say he agrees with me. It's like, all right, now I got someone who's more accredited saying the same thing as I am. Now will you guys look into it? And they're going to go, no.
Right.
That's what it feels like when
Yeah.
I'm on the side. And so for me, it's until the side sees the problem that we're seeing and addresses it fully, it doesn't go into some rhetoric or another, like we tend to say, like a circle jerk. The flat earthers, we do like to tease each other every once in a while, but I don't think it's made out of hate.
Sure.
And so until that happens, it's just gonna be a stalemate, really. And while I like what you're trying to do, because as long as we can talk to each other civilly, whether it's a belief or it's not a belief, whether it's through science or whether it's through something else, it's we're going to get closer to it as far as figuring things out. And maybe I mean, for me personally, I don't think I'll ever go into outer space. I don't think you'll ever go into outer space. I don't think my kids will ever go into outer space. I would love to, because I love outer space. I love science fiction. We could talk about science fiction in space type of movies forever, or even books, and I'm there with you. And I'm 40 now, and they, before I was even born, they landed on the moon 5 out of 5 times. Now we can't seem to go there, and they're planning to in the next within the next 10 years. See how that plays out, and then what happens next 20 years. So if I'm 70, I'm 80, I'm 90, we're still not there. It's like, all right, all this stuff about space, and we're going to get there. We're going to get people to Mars. We're going to colonize a different planet. We're going to explore the galaxy. That stuff is probably never going to happen. And I think more people are going to realize that as time goes by, because just look at how beautiful it is, how they present outer space, the universe. I mean, it's just spectacular. I mean, I loved watching the Hubble telescope's astronomy picture of the day. I was
Right.
on it from, like, once that website was up back in like the 2000s. I was looking at that every day, just these high resolution photos, and I was just mesmerized. And then another decade goes by and nothing happens. Another decade, and you start to get a little bit depressed. But whether it happens 100, 200, 300, 400 years, great. I mean, it won't matter to me at all anyways. But what I can appreciate is the history that got us to this point, and that's what I enjoy, and that's what I have been enjoying. And whether I'll be wrong, and who's going to remember me in 400 years when we're actually living on Mars? But if we're not living on Mars, they'll remember me differently, right? So it really depends on the future when they look back and say, hey, did someone ever even just think about that maybe the Earth wasn't round and that there was no such thing as outer space? Did anyone even just question that? I mean, 100 years from now, did they ever go, hey, I mean, come on, someone must have questioned it. So that's where we're here at. We're questioning. So that's where we're at, you know?
Yeah, I think space, because we love science fiction, and we love science fiction movies, and we love kind of fantasizing about the future, and people zipping around in their own little, personal jets that you could fly, fly anywhere to anywhere, and it's very appealing. And I think the people who are running the space companies, they love that stuff too, and they want to kind of put a rosy picture on it. I mean, it's like if you look at the Elon Musk's Mars presentation, it's like, hey, sign me up, and it's like, what if you actually take a look at the data? It's really, really hard, and it's really, really expensive. Go ahead.
Sorry, I didn't mean to interrupt you. I was just wondering, how old are you, and do you think you'll ever go to space in your lifetime?
I'm 52, and I don't think I'm going to go to space just because, and this is something I was actually going to get to, is like, space is extremely hard, extremely expensive. And there is this progression. I don't know how to express it, but if you think about mankind living on Earth, and it isn't necessarily a linear path, but I'm just going to sort of take you on a journey. So mankind lives on Earth. So it's like gravity or density and buoyancy, it holds stuff down, so you set down a cup of water and it's not going to fly away. Okay. Well, then how do you get your food? Well, you can grow plants, or you can hunt animals, or you could raise livestock. And they're stuck to the ground as well because of gravity, or density buoyancy. So living on the ground is really, really easy. Well, let's make it a step harder, and let's dig underground. And so let's dig like a coal mine. So you're hundreds of feet below ground. Well, you don't have any light, so you can't grow crops. Well, okay, so then you're gonna have to have some sort of power generation, and then electronic lights, so that you can grow. I mean, like, I think there's a bunch of marijuana farms where they use it as shipping containers and they bury them. So I think you see where I'm going with this, where it's like, it's really easy to live on the surface of the Earth. It's really hard to dig and then like literally live underground, right? You may have access to water, you may be able to grow food, with lights, but it's a lot more difficult. And then the question is, like, where do you get your air? So you're gonna have to have a shaft that goes up to the surface to get air. Well, then extend out onto the water, and it's like, what does it take to live on a boat? It's like, well, you got no supply of fresh water, so you have to figure out how to get fresh water. Maybe you could fish to get food. There's no way of growing crops. So you're really limited as to, the kinds of food you can have. And then, like, people get scurvy because they didn't have enough oranges, So it's really, really hard to live on the water. Well, then you go underwater, like, living on a submarine. It's like, it's just times 100, difficult. Well, then you go up into the air. And so, like, let's say you live on a dirigible, like a rigid airship. Well, you have to bring all your food with you. You don't have a supply of water, so you have to bring all your water with you, or you could try to distill it out of the air. I mean, do you kind of see where I'm going? Where it's like, it's like 1,000 times harder, or it's 10,000 times harder. Well, now you go to space where you don't even have oxygen, and then usually you're in a microgravity environment, so you don't have gravity. Do you see how it's like, it's 1,000,000 times harder? So I think that space has been oversold. And then, to get back to your question, do I think I'm going to go into space? And the answer is no. It's extremely expensive, and it's extremely difficult. And it kind of isn't worth it. Like, I mean, maybe, like, it's great. It would be a great ride, but it wouldn't be worth it for me. Like, I'm not an explorer type. That was a super long answer, but does that analogy kind of make sense with, like, the difficulty, raising the difficulty factor with those different living conditions,
Yeah, I understand. Like, for me, I'm different. I am an explorer, and if I was given a chance to go to outer space, even though I think it's all a lie, I would still do it. Most likely I'll die, I have a feeling, but that's fine. I want to make that attempt. And I'm not living my life in fear. So if there's a chance, I'm telling anyone, NASA, you guys need someone to train and live out in space, I'll do it. You guys don't even need to pay me. I'll do it. As simple as that.
Oh, good.
And that's the thing is I didn't get to say much in the non sequitur show with Red's Rhetoric talking a lot. Is he put a lot of words in my mouth, like I'll sacrifice a bunch of people. No, sign me up. I'm the first to sacrifice.
Right.
And so what I was mentioning was it was back a couple of years ago. I'm not sure if it was over a decade or two, but they had this private space agency saying, hey, we could build a ship that'll take you to Mars to start the colonization process, except it's a one-way trip. And I think hundreds of thousands of people actually submitted applications to join. I think I might have been one of them. I'm not sure.
Sure.
But there's a selection process that they had, and they actually picked one, I think. I think their plan was to raise money by trying to find
lottery.
Yeah, to find out who is probably the best capable of surviving in Mars, and that's how the selection process was going to work. And so many people want to do it, and I'm pretty sure some flat earthers who think NASA faked the way to the moon, they would sign up too. I'm one of them, because we just really want to know what the truth is, and if we're wrong, we're still going to be happy because look, we're going to Mars. Right. We're going to be the first ones to Mars. So it's no matter what, you can look at things bad in a bad way. But, if you look at things in a good way, something bad might happen to you, but something good's going to happen to humanity. So if you try to think of things in that perspective, it's good.
It's you definitely do sound like an explorer. The thing is, you've got kids as well, so that of course factors into it. I've got wife and 4 kids, and I'm really kind of grounded. I'm not even leaving the state of Pennsylvania because my sister and my mom live here, and so it's like I'm definitely not. I'm not cut from the explorer cloth, but. Then this is an abrupt change of subject, because you were asking about the North Pole and how they were constructing the meter. So the key for them, and I don't know if you know about the French geodesic or geodetic experiment or expedition. I think it's called the French Geodetic expedition, and it was in the 1730s, if I'm not mistaken. So this is what, 300, almost 300 years ago. And they wanted to figure out if the Earth was oblate or prolate or spherical. And the thing is, Newton had predicted that it would be an oblate spheroid because it is turning on its axis. So Newton said, well, it makes sense that the equator would be slightly wider, just by a tiny bit, than going, say, on a meridian, north-south. And well, they didn't know. Actually, there was a French mathematician, I think it was Descartes, actually argued that the Earth was a prolate spheroid just because, I don't know, he liked the shape better. He didn't have any physics behind him, but they genuinely didn't know, because when you look out of the ocean, the Earth appears flat. You could see a horizon, so you figure, okay, maybe there's a curve, maybe it's a globe, but you can't tell by looking at it whether it's oblate or prolate. And so they sent out surveying teams. They sent one to Ecuador, or what's modern day Ecuador, and they sent another one to, I think it was called Lapland, which is, I guess, modern day Finland. So it's as close to the Arctic Circle as they could get by land. And they literally surveyed using, these huge theodolites, very high precision theodolites. And they found that the Earth was oblate. Well, once you know that the Earth is oblate, well, you can then tell what the circumference is, using a variety of techniques. The Eratosthenes was one of the first ones, but you don't have to go to the North Pole to find out the distance to the North Pole. Does that make sense?
I think that might be a possibility, but where are they basing the North Pole at? The magnetic North Pole?
No.
Under Polaris?
Right. Yeah, and Polaris is not directly at the North Celestial Pole. You just look at where the center of rotation is. So people say Polaris, that's a shorthand. Polaris is actually, I think, about a full degree. It's like 2 full moon diameters away from the North Celestial Pole, but it's close enough that it's good enough. So people say Polaris, but it's the North Celestial Pole, and you can use surveying instruments to figure out how close you are. If the entire rotation of the stars is at 90 degrees over your head, well, then you know that you are at the north, the geological North Pole. I forget the name of it. The actual North Pole, the actual turn of the Earth's axis, where that intersects the ground. I think you had a video on that. Talk about the South Pole, but yeah. So that's how you know where the North Pole is you're looking 90 degrees overhead to the center of the rotation of the stars overhead. Does that make sense?
Yeah.
And the same thing with the South Pole.
Do you? So, if you look at the top 3 search results of Google, and one of the things that I like doing is I just like to use the mainstream, what the majority of people would use to look up answers. So, majority of people would use Google still,
Sure.
even though a lot of people within the YouTube community, as far as content creators, would go, no, Google likes to censor and do a lot of wizardry behind their algorithms. But for me, it doesn't matter. I'm looking at it from a perspective of just the mainstream, the normal Joe, where they're just gonna look up on Google and see what the top answers are and look at the top answers, and most of them are going to look at the Wikipedia and not even worry about what source is cited within the Wikipedia at the bottom. But I still like to look at it just to see what they find. And what I find when I start looking into Eratosthenes and how the Earth was proved to be a globe, and how they found the circumference of the Earth. And there's 5 major assumptions that they even say within the Wikipedia that Eratosthenes had, and one of them was he had to assume that the Earth was a ball.
Yeah, because Eratosthenes wasn't trying to figure out if the Earth was a globe. He was just trying to measure it.
Yeah, but if the Earth wasn't a globe, he wouldn't be able to measure it. So in order to measure it, he had to make the Earth a globe in order to get the measurements of the circumference.
Yeah. So and here's where you're talking about history, and in Eratosthenes' time, it was pretty much common knowledge that the Earth was a globe. They like I said, there's a lot of evidence, and you were asking about, and I don't mean to change the subject. You were asking about what if you didn't have telescopes or P900s or whatever? Like, could you figure out the shape of the Earth? And it's like, that's what my channel is all about. Because yes, I do like people to have a good digital camera, but those are pretty commonplace. But using a protractor, you can actually figure out the shape of the Earth. At least you could figure out that it's not flat, and you could figure out that the globe Earth perfectly matches what you see or what you can measure using very simple tools, most of them protractor based. But Eratosthenes knew the Earth was a globe, so that was his starting point. But he was estimating the number of miles between, I guess, what was it, Syene and Alexandria.
It was stadia. They didn't have miles yet.
Right. They had stadia. It was like 500 stadia. Well, that sounds like a very round number. So it's like, that was maybe that was a round number. Maybe they were going by like how many days it took them to travel the distance or something, and there's a lot of folklore. Go ahead.
Yeah. And an interesting tidbit that they put in, and it's not just Wikipedia, but other sources, is that he never left was it Syene? He never left
Alexandria.
Alexandria. There you go.
Yeah.
In order to. So
now the thing is, there's many versions of the story, and like I said, the story has become folklore. Most people on the flat Earth debate that they call it, 2 sticks in the ground. But my understanding, because like I've done a fair bit of reading on Eratosthenes, and so it's like I went beyond, like, say, the Wikipedia entry. I actually tried to go back into like historical sources. And again, that could just be fiction. All right. So I'm just put an asterisk next to it. But what I read was that he was the librarian, I guess, at the Library of Alexandria, and he stumbled across a reference to this phenomenon at Syene, that somebody looked down at it was high noon on I guess it was the June solstice.
It was the summer solstice, yes.
Yeah. Well, I don't like to say summer solstice. I mean, yes, it was, but it was June because it was the Tropic of Cancer.
The thing about it is we never used to have 12 months. We only used to have, I think, 9 months.
No.
So yes. So sometime during the Roman Empire, they added 3 extra months.
No, that is completely the only thing that's changed about the actual length of the year has been like the precision of, is it
You're
365? Is it 366?
Yeah. Before you
Because
go on,
if you look at the stars, if you look at the stars, they will make one complete cycle in 365 days. And the thing is, they'd studied the stars for 1,000 years. I mean, without telescopes, you could study the stars. So the idea that the Earth had, or that they had a 9-month calendar, is like, let me put an asterisk beside that. If there is a reference to a 9-month calendar, it wasn't a 9-month calendar where we say, oh, here's the equinox and here's the solstice. It might have been a 9-month calendar in terms of, like, we have fiscal years in this country which don't line up with the calendar year. I mean, it's a fiscal year is still 12 months, but do you see what I'm saying? Like, it might have been just for convenience, but they still knew when the solstice was. So, getting back to,
Sure. But look, here's an interest, just something interesting. Like,
sure,
you're good with math. Like an octagon, how much is that? What number is that?
well, that's 8. Yes.
But it's 10 in our current calendar.
Well,
No,
October, right. October.
Yeah.
Neuve in French is 9. 10 in French is 10.
Mm-hmm.
So yeah, I totally get it.
We're off by 2.
Right, we're off by 2 for a few of those months.
And August.
I forget.
It's based off of Augustus Caesar.
Oh, right. Okay.
Who they added the 3 months, one to be in honor of him, and another month for someone else. And anyways, that's just history tidbit. Doesn't really pertain to this topic. It's just a little reference that I like to point out.
And it would be something for me to look into. Like, I'll have to look into that. So I don't want to just dismiss, even though I did verbally say that there was never a 9-month calendar. What I meant was they were never under the impression that the Earth took one turn around the sun in 9 months. That was what I was trying to say. Okay. Yeah. And I hope that makes sense. So, but my understanding about Eratosthenes is that he read in a book in Alexandria that there was an observer who just noticed this strange phenomenon. It was just a coincidence. He looks at the bottom of the well. It happens to be high noon. It happens to be at Syene, and it happens to be the summer solstice or the June solstice. We'll call it the summer solstice, because who knows what the date was,
Mm-hmm.
But they knew when the sun was highest in the sky, and he could see clear to the bottom of the well with no shadow. So this was just a reference. It was an anecdote that Eratosthenes read. And so without leaving Alexandria, he was able to then, the next summer solstice, he could then make a measurement in Alexandria without ever leaving town. Does that make sense? Because he knew it was like every summer solstice, the Earth's rays would hit the bottom of that well. In other words, they'd be at 90 degrees overhead. Does that make sense?
Yeah, I understand the history of it.
So, but a lot of people on the globe Earth side, they think that he put 2 sticks in the ground, or he measured a stick in Syene, measured a stick in Alexandria.
That's because NASA.gov, when they educate people, that's what they point to. They point to the sticks and not the well, which is pretty funny.
Well, the thing is, it's more of a folklore type tale, but does anything ride on that? And I would say nothing rides on that, other than that was the first semi-accurate estimate of the Earth's circumference. Like, it's a footnote in history, but anybody can do it today. So it's like, if it's something where the exact details don't really matter. Another thing is like Thomas Edison. I mean, this is a really abrupt change of subject, but I was taught for my whole life, Thomas Edison, he tried 10,000 things for making a light bulb, 10,000 filaments, and I think a lot of other people, he tried 10,000 different ways to try to make his filament for the light bulb. I mean, have you heard, you've heard that story, the 10,000 failures before he invented the light bulb. It turns out that story is a heavily folklorized version of the actual story, which was once he realized that whatever filament he was picking, it was burning out because of the oxygen in the bulb. And so his breakthrough was to remove the oxygen from the bulb. And as soon as he did that, it didn't really matter what the filament was. I mean, I don't know if he used tungsten or whatever, but that's kind of what we use today in old-fashioned light bulbs. But so it wasn't like this huge 10,000 step search for the perfect filament. It was, how come these things keep burning out? And then he stumbled upon, I think it was like he was looking at a pile of charcoal that, was like a whiskey distillery, and they were making their own charcoal, and they were like very carefully controlling the oxygen by piling dirt or something on it so that it was a very slow smolder. And he was realizing, hey, if I reduce the oxygen, maybe it won't burn out. And then that's when he invented the light bulb. So the point is that the exact specifics of the story isn't important. What is important is that Thomas Edison never gave up. He never gave up in inventing the light bulb. And what's important in the Eratosthenes isn't the exact details of how he did it. It's that he did do it, even if it's been, gone through the folklore ringer. Does that make sense?
Yep.
But I mean, it's something that people can do today. And there have been a lot of coordinated efforts where people are like, hey, usually the equinox is the better day, because if it's the equinox, then we know that the sun is directly above the equator. So it really doesn't matter where you are on Earth. You're like, okay, on today's date of the equinox, the sun's above the equator. I know how far I am from the equator. Let's measure the angle of the sun. And so school children all over the world do it every equinox, and they measure, with pretty decent precision, the circumference of the Earth, if that makes sense.
Mm-hmm. One of the things that I like to think about is, imagine Eratosthenes just taking the assumption that the Earth was round out of the entire measurement of the circumference of the Earth. That measurement wouldn't be a circumference. It would just be called, say, a meridian of the sun's direct overhead travel path. It would still be the same distance. It just wouldn't be called a circumference, because it would just be a flat measurement and not a global.
No,
measurement.
it wouldn't be a circumference at all.
Yes.
Because his measurement was an angle. And so the angle at Alexandria, which was, I think it works out to like 3.5 degrees or something like that.
Yeah, it would be the angle off the meridian in the flat equations. It would still be the same distance.
No.
He didn't account for the curvature of the Earth. So
no,
I'm just trying to have you think about it in the flat.
Yeah, no. But what I'm saying is, like, I've actually studied the geometry of it. Okay. And I've actually studied what the geometry would be if the Earth were flat. So, I mean, this is something that I've actually spent a great deal of time on. And the way he did his measurement is he knew that if it was I'm just going to say 500 stadia. I think that was, wasn't stadia, 500 stadia between Syene and Alexandria. And that it turns out that angle of the sun was at 3.5 degrees. Well, you multiply 500 by, or I should say, you divide 360 by 3.5 degrees. And you figure, well, how many increments do you go around the circle? So, I mean, you need 360 degrees to have it work. On a flat Earth, there is no 360 degrees along a meridian. Like that number literally doesn't make any sense.
There's 360 degrees on a horizon, which if you go
from
one end to the other is still 180 degrees. It'll still work, because
that's not what he was doing, though.
Yeah, I know. He made it a full circle.
But but it was a full circle. It was a great circle. Whereas it wasn't a 360 horizon. Does that make sense?
But he used the 360 to make that circumference.
Right. But the 360,
he could still use 180 and came up with a meridian, or whatever you want to call it, on a flat plane.
Yeah. Well, the thing about the flat Earth, like, okay, so let's go back in time. You're Eratosthenes. You know the Earth is flat, and you measure the angles of the sun. You know that the sun is directly above Syene on the summer solstice. And then you measure the angle, and you find that the sun is 3.5 degrees from Alexandria on that same date. No part of any of what I've just said has anything to do with 360 degrees. Like, do you see what I'm saying? Because what you have is 2 points on a map. One is directly north of the other. 2 points on the map, and the distance between them and the angle. So what would you do, Mr. Eratosthenes, who believes the Earth is flat? You would calculate the height of the sun. That calculation literally has nothing to do with the shape of the flat Earth. Does that make sense? Because there's no 360. You don't know if the Earth goes for 10,000 miles in that direction, 100,000 miles in that direction. Like, there's nothing about that tells the scope of the Earth. It's because it's flat. You know, the only thing you could do is you could triangulate how high the Earth was or how high the sun was, but you definitely couldn't figure out the circumference of the Earth, of the flat Earth, I should say.
Of course, there wouldn't be a circumference on a flat Earth, but it'd be similar how they use sextants in order to figure out how far, say, a landmass might be just by looking at objects in the sky. They don't use a globe Earth model where they have to figure everything out of 360 degrees. They just use the angles of based off of the sextant, which 180 degrees is perfectly fine. You don't have to go the full 360 degrees.
Yeah, no, but I don't think you're understanding that whether you use 180 or 360, you're still talking about literally a cross section of a sphere, which is a circle. You know, where like the core of the Earth is at the center of the circle. But if the Earth were flat, there is no, like, literally degrees of latitude don't make any sense on a flat Earth. I mean, you know, okay, everyone's seen the flat Earth, you know, the common flat Earth map, whether it's the map or not. And of course, everyone knows latitude and longitude, but those numbers don't represent wrapping around the great circle of the Earth, the meridian.
I think this is where our differences of opinion will have to be different.
No, but the thing is, we can,
for me,
you know, yeah.
Oh, sorry, go ahead.
What I was going to say was, you know, and the purpose of this conversation was not for me to beat you over the head with, you know, the Earth as a globe. But one of the things I do try to do is I try to clear up misconceptions. And so like, you know, if there's somebody who says, oh, well, you know, XYZ, and it's like, it turns out XYZ is actually factually incorrect, I try to, you know, and I try to be gentle about it. I mean, so I hope we weren't trying to battle each other too badly. But if it's a genuine misconception, I want to try to clear that up.
Sure.
Without resorting to like dogma, you know?
Yeah. For me, I just tried to look at things with the lowest common denominator. And I'll say 1/2, and then you're saying 2/4. It's like, you could just use 1/2, and you're saying, no, it's 2/4. So, you know, that's where we're going to have to leave it.
Okay. But so we're nearing, we're pretty close to the 1 hour mark. I did appreciate getting to know you a little better and having this conversation. I didn't mean for it to turn into a globe Earth, flat Earth proof or whatever at the end. So I hope that wasn't, you know.
But, I mean, it just shows your passion, and that's good.
Yeah.
So I'm not gonna be angry at you because you're passionate about what you like.
But I would encourage you to check out some of the explorations on my channel. The purpose of my channel is to get people to get outside and make careful measurements of the sun, moon, and stars. And they will reveal, you know, a lot. And it's not about the shape of the sky, which is a hemisphere. It's about careful measurements of things in it. But do you want to have any final words before we wrap up?
No, I mean, I'd like to join in at a future time. Panels are great too. And just thank you for letting me have this conversation.
All right. So Ebon, Kim, it's been a real pleasure meeting you. And I thank you very much for everybody in the chat. I'm sorry I wasn't able to address, you know, the stuff in the chat because I was focusing on what Ebon was saying. But thank you for joining us. And this is Charles Breeling, aka Flat Earth Math, signing off. Thank you so much. Bye-bye.
Bye.